everyone. Today we are going to discuss the third chapter, that is stoichiometry. The first definition is, what is stoichiometry? It is the theory of proportion in which the chemical species combine with each other. It means stoichiometry is the theory that will identify the number of elements involved in a reaction. The next, stoichiometry equation. Stoichiometry equation of a chemical reaction is the statement that indicates the relative moles of reactant and product taking part in the reaction. For example, in the synthesis of methanol from carbon monoxide and hydrogen, the chemical reaction will be 1 mole of carbon monoxide reacts with 1 mole of hydrogen, gives rise to 1 mole of methanol. But as per the stoichiometry equation, it would be 1 mole of carbon monoxide, 2 mole of hydrogen and 1 mole of methanol, because in stoichiometry the number of atom in the reactant should be equal to the number of atoms of the element in the product. For example, here the carbon in LHS is equal to 1, whereas in RHS the carbon atom is 1. Similarly, oxygen is 1, hydrogen is 4, and here that is 4. Now let's come to the next definition, that is stoichiometric coefficient. It is the number that precedes the formula of each component involved in the stoichiometric equation. The same example, the synthesis of methanol. The stoichiometric coefficient of carbon monoxide is 1 and hydrogen is 2. Now let's come to the stoichiometric ratio. Stoichiometric ratio is the ratio of stoichiometric coefficient of the two molecular components involved in the chemical reaction. Here, in the synthesis of methanol, the stoichiometric ratio of carbon monoxide to hydrogen is 1:2. Now let's come to the next definition, that is stoichiometric proportion. Two reactants A and B that are taking part in a chemical reaction is said to be in stoichiometric proportion if the ratio of moles of A and B in the feed mixture will be equal to the stoichiometric ratio obtained from the stoichiometric equation. For example, in the synthesis of methanol from carbon monoxide and hydrogen, the feed mixture contains 10 mole of carbon monoxide and 30 mole of hydrogen. So the ratio will be 1:3. But stoichiometric ratio is 1:2. So the carbon monoxide and hydrogen are not in stoichiometric proportion. But if the feed mixture contains 10 mole of carbon monoxide, and instead of 30 kilomole of hydrogen, it will contain 20 kilomole of hydrogen. So the feed mixture ratio will be 1:2. And in this case, the carbon monoxide and hydrogen are in stoichiometric proportion. Now let's come to the another definition, that is limiting reagent. A limiting reagent or limiting agent in a chemical reaction is the reagent that is totally consumed when the chemical reaction is completed, or it is the one that decides the extent to which the reaction will proceed, or in other way, this is always present less than the stoichiometric proportion relative to the other component. So limiting agent is an agent that is present in the reactant site. Now let's come to the excess agent. The excess reagent or excess agent of a chemical reaction, each one that is present after the total consumption of limiting reagent, means it is present extra. Then the second statement, it is not the one that decides the extent to which the reaction will proceed. And in other words, the excess reagent is always present higher than the stoichiometric proportion relative to limiting reagent. Now let's discuss the example. In the synthesis of methanol from carbon monoxide and hydrogen, the feed mixture contains 10 mole of carbon monoxide and 30 kilomole of hydrogen. The stoichiometric proportion will be 1:2. The feed mixture proportion of carbon monoxide to hydrogen is 10 divided by 30, that equal to 1:3. Now let's check out in the feed mixture whether carbon monoxide is higher or hydrogen is higher. In the feed mixture, hydrogen is present higher than in stoichiometric ratio. So, hydrogen is the excess reagent and carbon monoxide is the limiting reagent. Now, let's come to the empirical formula. The empirical formula is the simplest atomic ratio between the elements of a compound. It doesn't necessarily represent the actual number of atoms present in the molecule of a compound. It is just the ratio between the numbers. Whereas the molecular formula represents the actual number of atoms of each element that occurs in the smallest freely existing unit or molecule of the compound. For example, one molecule of ethylene has a molecular formula C2H4 H because it contains 2 atoms of carbon and 4 atoms of hydrogen, whereas the empirical formula is CH2. It is just the ratio of numbers.